This is the free fall equation. It tells you how far something has fallen given a certain amount of time. And you probably don't understand where it actually comes from and how we get things like this 1/2 or why time is squared. So I want to start by breaking down the equation into its separate parts. So here's the height, represented by h, gravity, which is 9.8 meters per second squared. It's the acceleration due to gravity. And then finally we have time in seconds. So where does this equation actually come from? Let's start with what we know. Acceleration due to gravity is constant. And so a graph of that would look like this. It remains constant at 9.8. Then, whenever you get to the velocity, trying to figure out how fast it's moving at different points, it's basically just a linear graph. Because this is saying every 1 second, 9.8 meters per second are added to the velocity. And so after 1 second, it's 9.8. After 2 seconds, it's 19.6, and so on. And the equation used to represent this would be velocity equals acceleration times time. In the case of gravity, this acceleration would be the value of gravity, 9.8, and so we use a special letter for that, g. The hard part is going from this to position. In order to really visualize what's going on here, let's look at an example. Let's say we have a baseball that is rolling to the right at 5 meters per second. And so after 1 second, it will have gone 5 meters. After 2 seconds, it will have gone 10 meters, 15 meters, and so on. And so that tells us that the position of this baseball is represented by velocity times time. Now, let's think about if there was something pushing on this baseball. There's a constant force being applied, causing it to accelerate at a constant rate. After the first second, let's say it's moving 5 meters per second. After the second second, it's moving at 10 meters per second, and so on. So every 1 second, it's adding 5 meters per second, starting from resting where it's at 0 meters per second. Now, how do you suppose that you would find how far a ball has traveled if initially it's at 0 meters per second and after 1 second it's moving at 5 meters per second? You can pause the video and try and figure that out. So the correct answer is that you take the average of these two speeds. And so if you find that the average speed that the ball has traveled within this 1 second is 2.5 meters per second, then you can just use this with this equation. And so the average velocity is 2.5 meters per second times 1 second means that it will have gone 2.5 meters. Between 0 seconds and 2 seconds, the average velocity would be 5 meters per second, and so it would have gone 10 meters total because it's 5 meters per second average times time, which is 2 seconds. We can apply this to our equation here. In order to find the position that something is at in a gravitational field, or the height that it has fallen, you can use this equation where height equals average velocity, so we'll just go ahead and put velocity with a star by it, times time. So how do we get this average velocity using this equation? Because we're just looking at velocity at different points. After 1 second, we know that it's moving at 9.8 meters per second. Well, we would have to do the same thing and take the average between its initial point, which is 0 meters per second, and its final point, which after 1 second, that'd be 9.8. After 2 seconds, it'd be 19.6. And so let's look at, after 1 second, what its average velocity would be. You would have 9.8 as its final velocity, and 0 as its initial velocity, then if you divide those by 2 in order to get the average, you would get that it was moving at 4.9 meters per second on average. Now, let's say after 2 seconds, it would be moving at 19.6 meters per second, and so the average would instead be 9.8. And what you may have noticed is that the only thing that changed in this equation was the final speed. And so this can actually be represented as just velocity. And so if you do that, it's always plus 0, so you can just take the 0 away. Then you can see that the average velocity at any point is just velocity divided by 2. And so in order to find the position, you have to have velocity divided by 2. So then what we can do is we can take velocity, which we know is gravity times time, and we can substitute it in for that velocity, which gives us the equation gravity times time times time. And this can be rewritten here to be 1/2 gravity times time times time. And time times time is obviously time squared. We have derived the equation for free fall, and the position across time will go on a parabolic graph. And so now let's look at an example of how we would use this equation. Let's say that I'm in the air and I fell for 1 second before hitting the ground. How far did I fall? Looking at our equation, we know that h equals 1/2 g times 1 second squared. 1 squared is obviously just 1. What is the acceleration due to gravity? 9.8. It's 1/2 times 9.8 times 1. 1 times 9.8 is just 9.8. And then 1/2 of 9.8 is 4.9. So the height that I fell from was 4.6 meters. Now let's say that you know the height and you want to find how far I fell. I fell from a building that is 19.6 meters tall. How long would my fall have been? Looking at our equation, we're going to have to rearrange it so that it's, instead of solving for height, solving for time. And so if our original equation is height equals 1/2 gravity times time, we can divide both sides first by 1/2 gravity, which would give us 2 times height divided by gravity equals time squared. And now if we take the square root of both sides, we find that time equals the square root of 2 times height divided by gravitational acceleration. And so, in order to find how long I was falling for, let's plug in 19.6. And then, of course, gravity is 9.8. We can go ahead and solve this inside. 19.6 divided by 9.8 is 2. So then that becomes 2 times 2 is 4. Square root of 4 is 2. So that means that I have been falling for 2 seconds.